Na festa do fim de semana, só um rolê bom. Ela chega e desencana com passo bem solto, passo bem solto, passo bem solto. Na festa do fim de semana. Festa do fim de semana, só um rolê bom. Ela chega e desencana com passo bem solto, passo bem solto. Na festa do fim de semana, semana, pana, 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 pana. Na festa do fim de semana. Pana, 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 de semana. Pana, 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 de semana. Pana, 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 de semana.
Hello everyone and welcome to a new stream. Today we are gonna do something a little bit different than before. Today we are going to learn OpenGL. At least we are gonna try to, right? Because that's what we actually want to do. We want to learn new things that could be useful, right? So here we are. We have some basic script, some basic code here. Let's see. And this shit doesn't even compile. What the fuck is this? What the hell is this? Wait. What do you mean it's not defined? Like, isn't this defined inside this header? Oh, that's a great start, apparently. Fuck that shit. So I guess I'm gonna create a new project, right? Probably I don't think it's a good idea to do this at 10 p.m. But we are gonna do it anyway. Because we can, right? So how does this shit actually work? But before we do this, I wanna actually follow a tutorial. Bro, what the fuck? Why did you log out? Okay, it logged in. Okay, good. Don't log out. Oh, I saw that iDubbbz I saw that iDubbbz content cop video that got a backlash, but damn. So Let's see. Also, let me check if I'm streaming properly because I don't wanna have incidents. I crashed, but yeah. Okay, I mean like my own stream. So now we are going to search one specific channel, and the name is the channel. Yeah, I watched this channel, and this guy taught me C++, and he is very good at explaining things. So let's see if that actually works. So what we have to do now? We have to follow this OpenGL Roche. Don't fucking do this!
My name is the Cherno, and welcome to OpenGL. Finally doing an OpenGL series, really excited for this. This is something that I probably should have done years ago, but here we are. Let's talk about OpenGL. So in this video, we're basically just going to cover what OpenGL actually is, how we can use it, what it can do for us, what it isn't, and also what this series is actually going to cover. So first of all, if you've heard of OpenGL but you're not sure what it is, you're probably relating it to graphics, and that's exactly what OpenGL is. OpenGL is a graphics API. Now API stands for Application Programming Interface, and what it basically is a bunch of functions that we can call to do certain things. In this case, since OpenGL is a graphics API, it allows us to do things with graphics. And specifically, OpenGL allows us to actually access our GPU, our graphics processing unit, which is our graphics card. And of course, being called the graphics card, it's pretty good at drawing graphics. And so in order to actually utilize this massively powerful graphics processor that we have in either a computer or a device like a phone, we need to actually use some kind of API to get access to that actual hardware. And OpenGL is just one of many APIs that actually allows us to access the graphics card and tell it what to do. We have other ones as well, such as Direct3D, Vulkan, Metal, and there are a few others as well. So in summary, OpenGL allows us to control our graphics card to a certain extent. Let's clear up some common misconceptions that people seem to have about OpenGL. First of all, a lot of people call OpenGL a library or an engine or something like that, or a framework. It's none of those things. OpenGL by itself, at its core, is just a specification. It's kind of like a C++ specification in that regard. It doesn't actually define any code or anything. What it is a specification that lists, hey, this function should exist, it should take these parameters, it should return this value. It's just a specification of what you can do with the API. There's no implementation there whatsoever, which means that it's definitely not a library, because OpenGL itself, there's no code for OpenGL. It's just a spec, right? Just a specification. So with that in mind, where do I download OpenGL? That's another really common question. And the answer is you don't really download it. OpenGL itself is, again, just a specification. So who actually implements it? Who actually writes the code that gets called when you call an OpenGL function? And the answer to that is your GPU manufacturer. So if you're using an NVIDIA GPU, then the drivers for that GPU, your NVIDIA drivers, are what actually contain the implementation of OpenGL, NVIDIA's implementation of OpenGL. And every graphics card manufacturer, AMD, Intel, whatever, they're going to have their own implementations. And of course, NVIDIA don't really have a meeting with AMD and decide, yeah, this is how we're going to write our code. That doesn't happen, right? So everyone's implementation of OpenGL is going to be slightly different, which is why, in a lot of cases, some things may work on NVIDIA drivers, on an NVIDIA GPU, but that same game might look a little bit different on an AMD GPU, or maybe there are bugs or stuff like that. But anyway, the point is that OpenGL is written by your GPU manufacturer, which probably will lead on to the next common misconception about OpenGL. It's open source. Where do people get this stuff? I get that it has open in the name, but it's not open source at all. You cannot see the code for OpenGL because, first of all, it's implemented by the GPU manufacturers. They certainly don't release their driver source code. Some that do, there are of course open source implementations of OpenGL, because if, like, I don't know, if I create a graphics card and I wanted to support OpenGL, I have to write a driver for it, and I may choose to put that on GitHub or whatever and have it be open source. But the implementation that your computer is running, probably if you're using like an NVIDIA graphics card or an AMD or an Intel card, you're not going to see the source code behind that implementation. So OpenGL can't really be open source, first of all, because it's a specification, no actual source code. But second of all, the implementation of OpenGL that you're using is most probably not open source. What OpenGL does offer, which excites a lot of people and causes a lot of people, unfortunately, to say, oh, OpenGL is so much better than anything else, is because it's kind of cross-platform. So what you can do is you can write OpenGL code, and that same code will run on Windows, Mac, Linux, iOS, Android, that kind of stuff, right? And so people immediately start to think, oh, well, OpenGL is superior to Direct3D because it runs on all platforms. No, don't stop saying that, please. I just realized with that last statement of mine, I should probably say, since this is the welcome video, this series is kind of going to be based on my opinion. That's just, I'm making these videos, so I'm going to give my opinion. You can choose not to follow it. I'm not in any way implying my opinion is fact. I'm just saying that from my experience in the industry working on central technology for EA, specifically game engine technology for EA, and having dealt with many different graphics APIs, I'm not the biggest fan of OpenGL. And the concept of because this API is cross-platform, it's kind of, you know, the best. That doesn't make any sense. Game engines do not implement a single graphics API. That's not how they work. If game engines are cross-platform, that is, they're not just made for an Xbox or something, or they're not just made for Windows, they have to implement multiple graphics APIs, because the fact of the matter is, usually the graphics API that is made for that platform, for example, Direct3D made for Windows by Microsoft, is going to be superior to an API that's kind of cross-platform. Now remember, the people actually implementing the code are not Microsoft. Microsoft specifically with Direct3D actually tend to work with GPU manufacturers to get better kind of code done and stuff like that. But at the end of the day, something like OpenGL, it's NVIDIA's responsibility to implement OpenGL for their drivers. And if they screw up, it's kind of on them. But the fact that OpenGL is cross-platform, therefore it's better than Direct3D or better than Metal. Metal is what Apple used for iOS and Mac. That argument is really kind of doesn't make any sense, because usually the thing that's native to the platform is going to be more powerful and better. That is to say that OpenGL as an actual specification is actually really simple, especially when you compare it to something more low level like DirectX 12 or Direct3D 12 and Vulkan. So in terms of the complexity of OpenGL, I think OpenGL is probably, like with Metal as well, Metal is a little bit lower level than OpenGL, but not quite Vulkan. I would say that OpenGL is probably the easiest API that you can learn right now. So OpenGL is really definitely worth learning. Vulkan, which is another one of those cross-platform APIs, is still kind of fresh and raw, and the drivers still need a bit more work. Just last week, for example, I've seen Vulkan restart Android devices because you called something and it crashed, and Vulkan's a bit difficult to get into, and I would only really advise you get into Vulkan at this point in time, which is September 2017, if you really either want to just have fun, or like play with it, or you have to implement it for some reason. But overall, I wouldn't really ship a game on Vulkan just yet if I can avoid it, because something like OpenGL is going to be way more stable. Anyway, I'm kind of ranting. This is kind of getting derailed. My point is that this series is going to cover OpenGL. I still think OpenGL is the best graphics API you can use for learning because it's just so simple compared to the other ones. It's a really easy kind of simple one to learn. And of course, it also is cross-platform. So if you're not a game studio, if you don't have a team of people making a game engine and you can afford the resourcing for actually implementing,
I'm alone. Yay.
You know, Direct3D for Windows, Metal for Apple, whatever, OpenGL or Vulkan for Android. Like, if you don't have those resources available, which most people watching this video probably don't, then OpenGL is fantastic because it is cross-platform, and it's simple, it's cross-platform, it's going to by far be the easiest if you want to ship a game on multiple platforms. So that's why we're learning OpenGL, because I do like OpenGL like for kind of small personal projects, but obviously if I was a AAA studio working on a game engine, this would probably be my last choice for an actual graphics API, because the API, first of all, isn't that good. DirectX 11, my favorite graphics API in terms of API design is probably Direct3D 11, And what ends up happening with OpenGL for a lot of people, especially if they're writing a game engine and a proper graphics rendering engine, is they'll actually tend to basically write a direct 3D kind of wrapper over OpenGL. So in other words, they'll kind of end up writing a framework which calls OpenGL under the hood, but on like the actual API of that framework will be very similar to Direct 3D, because Direct 3D 11 specifically is a really good way of creating a graphics API. Again, my opinion, but most people that I've talked to in the industry with this 100% agree. So yeah. So with that aside, you now have some answers to some frequently asked questions. OpenGL is implemented in your graphics drivers, and it's just a specification for allowing us to control the graphics card. Now, in this series specifically, we are going to be dealing with modern OpenGL. Now, modern OpenGL is something that you might have heard a lot about as well. This kind of distinction between legacy OpenGL and modern OpenGL. The reason that exists is because OpenGL was released in the 90s, and back then it was very different to what it was now. Back then, GPUs weren't as programmable and as flexible, I guess. You couldn't control them anywhere near as much as you can now, especially with these lower level APIs now. People are ultimately giving so much control, or I should say manufacturers are giving so much control to the programmers and developers, which of course is really good because we can optimize further for that. But OpenGL right now is a lot more kind of, I guess you could say, low level, or it gives you a lot more control than it did back then. Back then, it was like a set of presets. So in other words, you basically draw a triangle and then you say, I want lighting. So how do you add lighting to the triangle? You basically say lighting equals true. You enable OpenGL lighting, and then you tell OpenGL, I want my light to be here. Like it really is like a set of presets. It was like a set of presets to how do I get my graphics to work. And because of that, it was really simple to use. Legacy OpenGL is really easy to use. The code is quite short, but unfortunately with that, of course, it doesn't give you as much control. And we do want control because we want to implement some pretty crazy graphics things in this series. So the biggest distinction between legacy OpenGL and modern OpenGL is shaders. This term shader is something that you might have heard, you probably would have heard if you were at all interested in graphics, and it might kind of resemble the word shadow or light. Like some people can compare it to lighting or something. Forget that. A shader is program. It's code that runs on your GPU. That's what a shader is. It's a program that runs on your GPU. So if we write code in C++ or Java or C# or whatever language, it runs on our CPU, right? But since we're specifically dealing with graphics, for a lot of the time, we want to control exactly what the GPU does and probably move a lot of our code from the CPU to the GPU because it's going to run faster on the GPU. So that's where shaders come in. Shaders just allow us to write code on the GPU, and we definitely want to be doing that in this series because if you want to work out some complex lighting algorithms, for example, you definitely want to be doing that on the GPU instead of on the CPU, which you had to do in the past. So programmable shaders is the biggest kind of difference between the two, but there are also many other differences as we'll discover in this series. But just rest assured, if you're looking for a modern OpenGL series, we're going to cover modern OpenGL. We're going to go as modern as we can. The other important thing that I want to mention about this series is that we're not going to be making a game engine. We're not going to be making a graphics engine or a framework or a library or anything like that. We're going to be learning OpenGL. I'm actually going to have another series, which I hope to start in a few weeks, which is going to be how to make a game engine. And in that series, we are going to make a full-on game engine, a graphics engine, all of that, which will implement OpenGL as one of its rendering APIs.
Jesus.
So if you want to see OpenGL in an actual engine, a game engine, and how that works, then that series is going to be for you. But this series, we're actually going to learn how OpenGL works so that we can write that rendering engine and that game engine with OpenGL. And so because of that, in this series, we're not going to be wasting time writing like a material system, for example. We're just going to focus on the raw OpenGL code so that I can show you how OpenGL actually works and how you can achieve what you want. And then it's going to be up to you to actually implement that in your engine, or if you don't know how to do that, then of course my game engine series, which will come shortly in the future, will cover all of that. But this series specifically, we're going to be focusing on OpenGL, which is why in our main source file, which we'll have, we're going to be writing OpenGL code. We're not going to abstract that away or anything like that. This is going to be some raw OpenGL code. We probably are going to have to write some utility classes like for maths and also like loading shaders or textures and stuff like that because there's a lot of boilerplate code that can kind of get repeated a lot. But when we actually come time to, when it actually comes time to, let's render something on the screen, that's going to just be raw OpenGL code. We're not going to abstract that away at all. We are going to be writing OpenGL in C++ because in my opinion, that's the best language for the job. It is going to be cross-platform. I'm going to try my best to ensure that it is cross-platform so that anyone can follow along on Mac and Linux as well as Windows. We are going to be using Windows and Visual Studio because that is what pretty much everyone in the industry uses. That's what I'm used to, and that's what I personally believe is the best tool set, the best tool chain that you can actually use. In terms of actual topics that we're going to be covering for OpenGL, we're going to do 2D graphics, and we're going to do really, really fast 2D graphics and learn about batching and all of that stuff to actually write a very, very fast 2D renderer. We're also going to talk about 3D, of course, and everything to do with that, and implement some cool things. We're going to implement lighting, of course, and shadows, and deferred rendering, and physically based rendering, and just any post-processing stuff like bloom and screen space effects, screen space ambient occlusion, screen space reflections. We're going to basically do everything that you guys can think of and leave in the comments. I'm happy to implement pretty much any of that. I've done it before, and it should be really exciting to kind of get a set of examples together which you guys can explore and hopefully implement in your own engines or in your own games or anything like that. So I'm really excited for this series because graphics programming is one of my favorite areas of programming. But just remember, in this series, we're not going to be focusing on how to make a game engine. We're just going to be focusing on how can I achieve this in OpenGL. OpenGL is just one of the many APIs that exist for graphics programming, and this series is going to be specifically about how OpenGL actually works. If you guys are as excited as I am, then hit the like button. You can also support this series and all of my videos by going to patreon.com/thecherno. That's going.
Now let's go. Kill yourself. Okay.
Back to my OpenGL series. Hey, what's up guys? My name is Cherno and welcome back to my OpenGL series. So this is really the first episode of my OpenGL series. Last time we just talked about what OpenGL actually was, a little bit about how it worked, and also what this series would actually contain. If you guys haven't seen that video, then check it out in that corner. Today though, we're actually going to jump in and write some code. We're going to get some work done, we're going to get an OpenGL window displaying, and maybe even draw a triangle. With this series specifically, I want to take a more practical approach. With the C++ series, I did a lot of kind of explaining, a lot of theory before we actually started writing code. I still want to do that for this series because I believe it's very important to understand actually how everything works. But with these kind of first few episodes, I just want to get some code done. I just want to actually write some code and have something happening on the screen so that hopefully you guys can kind of feel that sense of progression a little bit better. And then what we'll actually do is end up kind of as that goes on, maybe once a week or so, have a bit of a theory video and just talk about how OpenGL specifically works or what actually happens behind the scenes. Now with that being said, our goal for today is going to be just to create a window. Right? I want to be able to have my operating system create a window for me so that my application is actually in the form of a window. And then hopefully the goal with that is that in the future we can draw all of our graphics inside that window. Now, this series specifically, I want to have multi-platform support, right? I want people who are writing this code on Windows, Mac, and Linux to also be able to run this code, and it should work on all three platforms. What that means though is that we need some way to set up windowing, and windowing, or in other words creating windows, is very, very platform specific. So in other words, the way that you create a window on Windows is you use the Win32 API, right? So you actually use the Windows API to say, hey, I want a window, because of course the way that you create a window is going to be specific to the operating system you're using, because that's like an operating system level thing. And that's what I probably would do if I was writing a game engine. I would probably just take the time to actually set up a window myself using the actual operating system's API for each platform that I actually want to support. This series though is not about how to write a game engine. That's going to be another series later on. This series is specifically about OpenGL and how OpenGL works and how to write OpenGL code. So we don't really care about how to set up a window and all that. We just want to write some OpenGL code. And so because of that, I'm actually going to use a library that will basically do that for me. And all this library is going to do is provide me with the appropriate platform layer. So in other words, it's going to provide me with an implementation of that windowing creation code and management code as well for Windows, Mac, and Linux so that everyone can follow along with that. And there are several libraries that allow us to do this. But the one that we're going to use is something called GLFW. And the reason that I like GLFW is because it's a really kind of lightweight library. All it's going to do for us is create a window, create an OpenGL context, and give us access to some basic things like input. That's all that it's going to do. It's not like SDL, which is like a full kind of they've actually got like a renderer there so that you can draw squares or triangles or whatever you want to the screen, and that'll be implemented in either DirectX or OpenGL, and that's like a whole kind of framework. I don't want any of that. We're going to be writing our own stuff. All I want to do is automate that first step of I want to create a window, and I don't want to have to write different implementations for each platform. I want this code to be pretty multi-platform, pretty portable, so I'm going to use a library like GLFW to just speed that up for me. Again, I could write it myself, but that would mean writing it 3 times for each platform, Windows, Mac, and Linux in this case, and that's just going to be a waste of time and not really the point of this series. So just want everyone to understand why I'm actually doing this. So yeah, let's go ahead and download GLFW. If you go to the URL that is in the description below, which is glfw.org, you'll be taken to this page. We care about basically 2 pages here. First of all, there's just download GLFW 3.2.1. It's exactly what we want, but also under documentation, there's actually some example code of how to create a window in GLFW. And you can see that it's very, very concise, right? All we have to do is basically initialize GLFW, and then we can just create our window, and that's it. It's as simple as that. If we want to make an OpenGL context, we just call this one function, and then we can start a basic loop to poll for events and make sure that when our window is closed, it actually closes. And you can see we can write OpenGL code right over here. It's very, very simple, and it's pretty much exactly what we need to get started. So up the top here, I'm going to go back to GLFW. So this download is actually for all of the source code. This is another thing that I want to mention. If this was a game engine series or something, and I was actually making a serious application, I would probably download the source code and build it myself. I would add it as a separate project in Visual Studio and probably compile it into a static library and then link it with my main application, just so that if I need to debug something, I have the source code right there, and there's really no downside to do that. I like having as much source code as I can in my project. However, this again is about OpenGL. We don't want to waste time with that. All I'm going to do is just get pre-built binaries for my platform and just build with that, right? So to do that, I'm going to go to download, and then you can see we have Windows pre-compiled binaries. So Windows actually has pre-built binaries. Linux and Mac, it says that you actually have to download and compile the source package above. There's a guide, so follow that if you're on one of those platforms. I suspect people will probably run into problems with that because it's not the most trivial task, and with like make systems like that, it just tends to be all over the place. So if you need help with compiling this for Mac or Linux, definitely join my Discord at thetrainer.com/discord. There'll be plenty of people there who will be happy to help you out with that specifically. But since we're on Windows, and we will be for the entirety of this series, I'm just going to download the appropriate binaries. Another note here, we have 32-bit or 64-bit binaries. Question I get all the time, which one do I get, right? A lot of people seem to think that, well, I'm running 64-bit Windows, so of course I want 64-bit Windows binaries. That's not correct. What you actually want, the architecture that matters is the architecture that you're building for, right? If we set up our Visual Studio project to build for Win32 or x86, then we want to get the 32-bit ones. If our application is being built for 64-bit or x64, right, that's where we want the binary. So it's actually what matters is the architecture, the platform of your application. So how you compile your application, not the operating system you're using. Of course, a 64-bit application won't work on a 32-bit operating system, but if you're on a 64-bit operating system like Windows 10 64-bit, you can run either 32-bit applications or 64-bit applications. So the one that you actually download is going to depend on what you compile your application with. So we'll just be using a 32-bit application because we don't need a 64-bit one. For more serious projects, I'd probably use 64-bit. There's no real difference. It's easy to switch as well. It's not like a whole deal. It's not like we have to write different code or anything most of the time. It's pretty much the same thing, but to keep it simple, we're just going to use 32-bit. So over here, I'm going to click on 32-bit Windows binaries and download that. Okay, so inside the archive that you download, there'll be a GLFW folder and a bunch of libs. We'll talk about setting all of that up in a minute, but first we actually need to create a Visual Studio solution. So over here, I've got Visual Studio Community 2017. I'm going to click File, New, and then Project. I'm going to make sure that I'm under Visual C++ and General and select Empty Project as my...
Okay, let's do this. So we have a new project here, right? Then we have can we specify the fucking destination, like, okay, the fucking location. So we have an empty project right here, and we will do this inside this. We would probably use the, I don't know, we will probably use, wait, let me just hop on a folder that I created. So we have this, and we will create a OpenGL. I will call it OpenGL Live. Yeah, and I would select the folder. That's where I will create my project, and the name will be OpenGL Live. Okay, let's create a new project. So we have it here, and then we have to download the fucking binary. So we'll use glfw, right? So this will create. This is pretty recent, honestly. So let's download this. Wait, what the? Wait, what? Wait, they already downloaded it. Like, I want the 32 binary. Do we have this? Yeah. So this is the precompiled. So now let's. I think we should extract this for this, right? Let's extract this. Okay. Wait, why do we have some JavaScript file? What the hell? Okay. So then we have one of this, right? Let's see.
We're just going to make a brand new project from scratch. In the location, I'm actually going to change the location from being in my documents to basically being C, Dev, YouTube, and OpenGL. You can set this to anything else. I like to keep all of my development kind of stuff under C Dev. That way, it's not in a user folder, and I don't have to deal with all of that. So just C Dev and then OpenGL or whatever. I've just put it.
I saved on the external drive
into a YouTube folder because, of course, this is for the YouTube series. I'm going to call this OpenGL and just click OK. Okay.
Did you know the average
what the? Shut the fuck up.
One of these things? These?
I don't
these are
fucking.
So we've got a Visual Studio solution and project set up. Everything looks pretty good. If you want to set it up properly and more or less just set it up in a nicer way, because the default Visual Studio way that it sets up new projects and solutions is a bit weird. Check out my video on my kind of favorite setup for Visual Studio for C++. So there'll be a link up there. I'm not going to go through all that right now because it's just going to take time and it's not really that necessary, but definitely check out that video if you want to know how I would set this up properly. So again, all we're doing today is we're trying to set up GLFW basically as quickly as possible. So under source files, well, one thing I'll actually do is
Wait, hold on. I think I have too many windows open. Let's close this one. Let's close this one and this one. So everything is in a single bar, and also we have more RAM space and less CPU usage, right?
click on the project name, I'll click on show all files, and then I'm going to actually make a new folder here called src for source. So this show all files mode actually will mimic.
Oh, we need to add the include and source. Okay. Right. Should we move this on the left side? I would probably do that. Let's just move it here. What the fuck is this? Move it here. What the fuck, bro? What are you doing? Where the fuck did you? Oh my fucking god, are you? So I will probably, this should probably stay on the top, but for some reason it's on the bottom, but I don't really care. Actually, we have this, wait, the hell is this? Let me open this. Okay, that's a simple solution. Okay, we don't have any physical folder, so let's add what the fuck. Oh, this is a filter. Okay. Okay. So let's create a new folder. Do we have a folder option? Oh wait, I think it's right here. Yeah, and then we put the src right here.
Our Windows Explorer file structure and directory structure and all of that. Again, that's all described in the video that I linked up there, so check that out if you're not sure. Under there, I'm going to add a new item. I'm going to call this application.cpp. This is going to be our main file. The file.
I will call this app.cpp, okay. Or simply application. Let me just follow this tutorial like step by step, like dot per dot.
With the main function, I'll hit.
Okay, we should create a new element probably, and this is a C++ file, so we need to create an application.cpp, right? So we have this. Easy.
Hit add, and I finally just have a normal C++ file in my project. What I'm going to do now is just basically include IOStream, make sure everything's set up. In main, I'm going to type in stdc out hello and stdc in.get. I like to do this just to make sure everything.
Okay, let's do the same thing. Let's include IOStream, and then let's create int main, and then probably stdc out hello world std, and probably something like this.
To include IOStream, make sure everything's set up. In main, I'm going to type in stdc out hello and stdc in.get. I like to do this just to make sure everything's set up and everything will compile. You can see we get this opening with hello.
Can we compile this? Let's try if that works. What the fuck, bro? What the hell? Am I fucking encountering errors already? What the fuck? Bro, what the hell? What do you mean? How the fuck is that? Oh my god, you are fucking joking, you stupid little cunt bitch. It doesn't work. It fucking we have already problems here. Jesus fucking Christ, what the fuck is this? What the fuck, bro? Let me fucking run the program. Jesus fucking Christ, you stupid fucking bastard. Let me fucking run this shit. Jesus fucking Christ. We didn't even start, and we are already having problems.
It's perfect.
Oh yeah, I'm already lost. Wait, what the hell? Wait, we should probably... How does this shit work? Why is this... Oh my fucking god. Can we... Hold on.
So now I'm ready to actually link you.
Wait, hold on, let me just...
Okay, so inside the archive that you download, there'll be a template. We're just going to make a brand new project from scratch. In the location, I'm actually going to change the location from I left folder, YouTube folder, click OK, and projects and solutions is a bit more Visual Studio, and it's not really that. Today is we're trying to set up GLFW basically as quickly as possible. So under source files, well, one thing I'll actually do is I'll click on the project name, I'll click on show all files, and then I'm going to actually...
Oh wait. So let's delete all of this. So let's go here. Hey, what the fuck you were trying to do? we have to create a new folder, src, and then we have to add a new element. Okay, now everything is done correctly. Application, .cpp, and let's create our IO stream, and let's create our start file that we will print hello world, and then do this, right?
We make a new folder here called src for source. You just have.
Let's see if that works. Yeah, it works. I usually don't use Visual Studio 2019. Like, I usually do this. I usually use a fucking command line and CMake for this. So it's, for me, it's a little bit unusual. I even forgot how CMake works. So that's great.
I have a normal C++ file in my project. What I'm going to do now is just basically include IO stream, make sure everything's set up. In main, I'm going to type in stdc out hello and stdc in.get. I like to do this just to make sure everything's set up and everything will compile. You can see we get this opening with hello, which is perfect. So now I'm ready to actually link GLFW and get it to work. If I go back to the GLFW website here under documentation, literally all I'm going to do here is just copy pretty much this source code just in its entirety, copy, and just paste it over here.
Okay, let's do this. Am I still streaming, by the way? I don't know. Let me refresh this page, because I wanna do everything on live stream. I wanna document everything. So let's go here, and now let's wait. And let's go here, and then we'll copy all of this right here. Let's copy this and paste it right here. So everything should be like that, right?
Okay, we're going to get a bunch of things not working because of course we need to actually set up the library. So let's talk about how we're going to set up GLFW in our project. I'm going to go to that zip archive that I downloaded with all of our libs. There are two things that matter for us here. Every kind of C++ library has include and also lib, right? So we're going to talk more in depth about how C++ libraries work and how to link them and all the differences between all that in a future video in the C++ series. It'll be linked up there if it's already made, but definitely check that out if you're not sure about how kind of libraries work in C++. But out of here, what we care about is the lib file. There's actually two here. The two lib files that we have here, you can see one's labeled with DLL. So this one's used for dynamic linking if you want to use the DLL to link at runtime. glfw3.lib is the one that we're going to use though, because that's just for static linking. We don't want to link glfw dynamically. We don't want to have to use a DLL file. There's no reason for us not to static link it, so we're going to link it statically. So what I'm going to do is under OpenGL, I'm just going to right click on there, hit open folder in File Explorer so that we actually get to our location of all of this. And what I like to do is in the solution directory, so this is the solution directory, the directory with that solution file, I'm going to make a new folder called dependencies. And inside dependencies, I'm going to make a folder called glfw. And then inside here, I'm actually going to put all the files that I want. So out of what I want in this actual arc, I'm going to make a new folder called dependencies. And inside dependencies...
Oh my fucking god, this fucking glasses. Okay. Let me just clean because it's fucking annoying when you have like stupid fucking, oh god. Oh my fucking god, why there is fucking oil? Holy shit. Jesus fucking Christ. I'm gonna break my fucking glasses right now. Just fucking, oh my fucking god. No, oh my fucking god, don't do this shit, please. Don't fucking clean this
Dependencies. I'm going to make a folder called GLFW.
So, hold on.
Dynamically in our project. I'm going to go to that zip archive that I downloaded with all of our libs. There are two things that matter for us here. Every kind of C++ library has include and also lib, right? So we're going to talk more in depth about how C++ libraries work and how to link them and all the differences between all that in a future video in the C++ series. It'll be linked up there if it's already made, but definitely check that out if you're not sure about how kind of libraries work in C++. But out of here, what we care about is the lib file. There's actually two here. The two lib files that we have here, you can see one's labeled with DLL. So this one's used for dynamic linking if you want to use the DLL to link at runtime. glfw3.lib is the one that we're going to use though, because that's just for static linking. We don't want to link glfw dynamically. We don't want to have to use a DLL file. There's no reason for us not to static link it, so we're going to link it statically. So what I'm going to do is under OpenGL, I'm just going to right click on there, hit open folder in File Explorer so that we actually get to our location of all of this. And what I like to do is in the solution directory, so this is the solution directory, the directory with that solution file, I'm going to make a new folder called dependencies. And inside dependencies, I'm going to make a folder called...
Wait, where? What the hell? I only have the bug here.
GLFW. And then inside here,
Let me just create a new folder, dependencies.
here I'm actually going to put all the files that I want. So out of what I want in this actual archive that I downloaded, I want include and I want libvc 2015, which is the latest Visual Studio version that we have here. We'll paste this into here. Of course, we're actually using Visual Studio 2017, although it won't matter for our purposes. It will still work. Inside here, I can actually delete that DLL file and the DLL lib as well. We don't need that, and include should just have everything we need. So now what we actually need to do is tell this project.
So let's have glfw here. Let's paste this.
That I want you to also include this folder for includes so that we can write code such as include glfw/glfw3.h, right? So we need to add an include directory. And then we also need to add this lib file to the linker so that the linker actually links this lib file in and it can match up all of the glfw functions.
What is this,
So let's take a look at how we might set that up. What I'm going to do is right click on OpenGL, hit properties. Now the most important thing here, let me just make this smaller. The most important thing here is that you're on all configurations, okay? And all platforms doesn't really matter. We're just going to stick with Win32 for now.
I need two fucking monitors for that because switching windows is so annoying.
But all configurations, make sure.
Jesus fucking Christ.
You're on all configurations and not like release. If you're editing release and you're actually in debug, it's not going to affect your currently selected configuration and you'll get errors. So we want all configurations. Under C++ in general, we're going to add an include directory. Now, what we could do, right, is open up our folder here and just basically copy this path and put it in there. Now, we don't want to do that though, because other people who will use this project might not be storing it in C, Dev, YouTube, OpenGL, blah, blah, blah. We actually want to make it relative to the project itself, and specifically I like making it relative to the solution directory. Now, Visual Studio has a macro for us that is actually our current solution directory. And if we open this tab here and go to macros, then you can actually type in solution directory and you'll see what it actually is. It's cdev youtube OpenGL / OpenGL. So basically what it is the actual solution directory that we have here, the directory that has this solution file. And we're actually going to base our include directory path from that solution directory. So I'm going to type in solution directory. That actually already has a backslash at the end, a trailing backslash. So next we'll go into dependencies, glfw, and include. In fact, all I'm going to do is copy that last part.
Hold on. Let me just set it up real quickly. So we have this part right here, right? So let's go here and let's add this solution there and this part, right? So can we? I think we need to include this, right? Let's check. We have 1, 2, 3, 4. No, we definitely need to delete one of them. So now let's try again. And we have 1, 2, 3 dependencies. Okay, let's apply this. Okay,
and put it over here. Okay, that is our include directory. If you want to make sure.
What the fuck? Wait. Wait, if we do this, it will throw an error. Where the fuck do you put the fucking... Wait.
Open folder in File Explorer so that we actually get to our location of all of this. And what I like to do is in the solution directory, so this is the solution directory, the directory with that solution file, I'm going to make a new folder called depend.
Okay, we need to move everything here. Okay, we just have this and we have to create the dependencies on this folder here. So everything should work now. And let's change something. Can you fucking change something? Please? Let's apply and then let's do this again. Apply again and we have no errors.
Dependencies. And inside dependencies, I'm going to make a
folder. Okay, let's
configurations. Make sure you're .a, type in solution dev YouTube, well, glfw. And of course, now that you've set that up, over here, this include glfw/glfw3.h should work because we start in this include directory, we go into the glfw folder, and there's glfw3.h. Okay, so that's how we can set up the include directory. Next, I'm going to set up my library directory as well.
So we got C++ on the linker.
The linker in general, I'm going to specify an additional library directory.
Okay.
It's going to be very similar to what we had before. It's going to start off with solution directory. Then it's going to go to dependencies. In fact, I'm just going to go back to my folder and copy the path. So under glfw, we have libvc2015, and there it is, right? So I'll grab that.
So let's go here. Let's do solution there. Then we get this, and then this, and then we copy this part right here, right? So let's do this.
Chuck that in here, and we're good to go. Under input, I'm actually going to specify which file we want.
Okay, so let's hit apply.
want to link. Now we don't actually need to link all of these. I don't know why they're here. They're here kind of by default, but they're actually included in the default library, so we can get rid of all that to keep it nice and clean and just type in glfw3.lib. So basically we're linking with this glfw3.lib file, default library, so we can get rid of all that to keep it nice and clean and just type in glfw3.lib. So basically we're linking with this glfw3.lib file. Again, if I'm going too fast or anything, I will make a video specifically about this in more detail. I just don't want to spend all day on this. So check that out, check that video out if it's already made. If it's not, then just wait. Now another thing we actually have to link with is OpenGL, but we'll deal with that in a minute. I'm just going to hit OK because that's all we'll need for now. You can see that all of our compilers go away. If we hit Control F7 to actually compile our application, you can see it compiles successfully. Now it's not going to link successfully because we haven't actually, you can see we're using an OpenGL function here, but we haven't linked with OpenGL. But the compilation succeeds, and that's kind of all we care about for now. Now, if I right-click build this, it's actually going to compile and link the entire application. So let's take a look at that. Okay, so we get a few things. First of all, we have an unresolved external symbol. Again, I'm not a big fan of looking at the actual error list. You should be looking at the output because the error list is just mostly lies. Well, not in this case, but it can be. And this always gives you more detail. Okay, this kind of default lib conflict, don't worry about that. That's just a warning, and specifically it's an annoying warning that we don't need to think about fixing even. It's not that important. This is important, however. We have GL clear is an unresolved external. We also have a bunch of Windows stuff that is unresolved now because I did actually delete most of the libraries that we linked against, so we'll bring some of them back in a minute. But the first one that we're getting, which we'll fix first, is GL clear. Okay, and we can actually get rid of that error by linking with the OpenGL library. So what's happening is we're getting a linking error. If you guys don't know how the C++ linker works, check out that video because I have already made that. But basically what the linker is trying to do now is find a definition for that glclear function. That glclear function definition is inside an OpenGL library file, so we actually have to link against that. So over here in additional dependencies, I'm just going to add a semicolon and type in OpenGL32.lib. If I hit OK, and I build this, you can see that that first error should go away. And in fact, now the first unresolved external symbol is just registered device notification stuff, which is basically Windows kind of API stuff. So let's go ahead and add that in. Now, before we do that, I actually want to show you one way that you can find these things. I've deliberately gotten rid of all the kind of Windows includes because I wanted to show you guys how this actually works and how to set it up kind of really from scratch. But if you see errors like this, because they actually do tend to be quite common sometimes if you're not set up correctly, you can see that the function name is actually registered device notification W. So let's grab that and copy that and actually Google that. So on MSDN, I'm just going to Google that. You can see we're actually greeted with MSDN here, which is the Microsoft documentation. So this is the actual function that we're trying to link, and we don't know where it is. So if we scroll down, you can actually see that the library that it's in is user32.lib. So what we can do is copy that and actually link with that, and that will actually go away. So over here, I'll just type in user32.lib, hit enter, hit OK, and try and build this again. You can see that we get way less errors now. We've only got just a handful now.
Why the
and
fuck
a few
did
of them will basically create device context here and swap buffers and all that stuff. So again, I want to do the same thing with this. I'm going to copy this. I'm going to go over here to Google, just basically Google that function, click on the MSDN link, scroll down, and you can see this one is in GDI32.lib. So back to my project, and I'm going to link against GDI32.lib. Okay, I'll hit OK and try and compile my code again. All right, just a few more now. Drag query file W, again, copy that, paste it in here, MSDN, and here it is, shell32.lib. So back over here, you guys kind of get the drift. Shell.
Kill yourself.
A 53 anni pensavo che ero...
The fuck is this shit? The fuck out of here.
32.lib. Okay, and build. All right, awesome. No errors at all. And if we hit F5 or just local Windows debugger to run our actual application, you can see that we get a black screen. Now, all this manual linking that I've just done, you don't need to do that yourself. When you create a new empty project in Visual Studio like we did, you can see it actually did have a bunch of links already,
yeah, it works.
Kernel 32.lib and stuff like that. I just wanted to get rid of them just to show you how it actually works and how to link everything kind of from scratch. You don't need to do that though, this was just kind of as an example. Now we got a black screen here, let's quickly draw a triangle. Now what I'm actually going to do to draw this triangle is use legacy OpenGL. So in the first video we talked about what legacy OpenGL was and why we shouldn't be using this. Legacy OpenGL is the fastest way that I can now, in like 5 lines of code, draw a triangle on the screen. And my purpose right now is just making sure that OpenGL is up and running, not writing again. I'm not writing a graphics engine right now, right? So whilst you shouldn't be using legacy OpenGL, like in, I guess, professional applications, it's perfectly fine for debugging. People need to realize that even though some things are discouraged, if you're just writing it temporarily to test something, there's absolutely nothing wrong with it. So just keep that in mind. So what we're going to do over here, under GL clear, is I'm actually just going to type in GL begin, GL triangles, and you guys will kind of get it to experience some legacy OpenGL code. So between GL begin and GL end, we just want to specify 3 vertices. I'm going to type in GL vertex 2f, which is going to...
Oh, I remember doing this. Actually. GL begin. We have GL triangles. Then we have GL end. Like this.
To specify a 2-component kind of vertex, or 2D, I guess, vertex. Now, by default, our projection matrix in OpenGL is between -1 and 1 in every dimension, in every axis. We'll talk more about projection matrices and all this fun stuff in future videos. Again, just trying to draw a triangle now. So I'm going to type in -0.5f, and then -0.5f for y as well. And then for my other ones, I'm going to maybe make this one in the middle, so it's going to be just 0f for x, and also +0.5f for y. And then this one's going to be +0.5 for x, and -0.5 for y. So I should be drawing a triangle that is basically in this shape. Let's hit F5. And you can see that I get a triangle that's perfectly...
Hold on.
And then this one's going to be +0.5 for x and -0.5 for y. So I should be drawing a triangle that is basically in this shape. Let's hit F5. And you can see that I get a triangle that's perfectly kind of in the middle of my screen and looks pretty good. Okay, so we can now conclude that OpenGL is working. And that's going to wrap up this video. We've basically accomplished everything we wanted to. We've got an OpenGL window. Everything right now is in our application file. We are probably going to move it just into a class or something just to keep it a bit more simple. We'll do that next time. But overall, again, we're not going to spend too much time creating an API for ourselves because we want to learn OpenGL. So we've got something up and running. You guys can recreate this code on your computer and hopefully get something as well, so you can finally make a nice little cute OpenGL application which draws a single triangle. Exciting stuff, I know. But as we go on, we'll kind of deal with more stuff. Now, for all of the code in this series, I do actually encourage that you copy it down yourselves, because when you actually copy code, even though you are just copying from a screen, you actually learn it because you're typing it out yourself. It's like when you meet someone new. A lot of the times you'll meet someone new, they'll introduce themselves and say their name, and then you'll just forget their name straight away. But if you actually say their name back to them, like, hello, Bob, then you're way more likely to remember their name, right? So kind of with this as well, I like the idea of people actually copying code down themselves and actually physically typing it themselves, because once you do that, muscle memory will kind of kick in and you'll actually learn a lot faster. That being said, if you really want the source code, I am actually making that available to patrons. So if you pledge on thechurner.com/Patreon, or sorry, if you pledge on patreon.com/thechurner, probably make thechurner.com/Patreon work as well. But if you go to patreon.com/thechurner and you pledge there and you help support this series, you will actually get access to the code on GitHub, and that will be separate for each episode as well, just like it is for all of my other series. So if you really want the source code and you really want to help support the series, it's just, you just get a reward for helping to support this series and making sure that I can make more videos. There's also a bunch of other rewards on patreon.com/thejourno. So I really appreciate all the help I get from there, and that's what basically lets me sit down and make these videos properly. So much appreciated. Anyway, next time we're going to abstract this out into a class and actually talk about modern OpenGL, because what we've done right now is we've created an OpenGL context and a window and everything, but we're actually only limited to using OpenGL 1.1, which is what ships with Windows. Windows has its own rendering API, DirectX, Direct3D, so they don't actually provide you with all the functions you need for modern OpenGL. As I mentioned in the Welcome to OpenGL video, that's provided for us by our GPU drivers. So what we need to do next time is actually somehow get all of those functions that are in newer versions of OpenGL out from our GPU drivers, so that we can actually, we want to be able to call the functions, right? So that's what we need to do, and that's what we'll talk about next time, as well as probably moving this out into a class and all that fun stuff. And then that's when the real fun's going to begin next time. So I'll see you guys in the next video. Goodbye.
Wow, wow, wow. That's good. That's cool. Skip this shit.
My OpenGL series. Hey, what's up guys? My name is Eterno and welcome back to my OpenGL series. So last time we set up an OpenGL windowing and context library called GLFW, which basically just gave us the ability to create a cross-platform window and initialize a graphics context for OpenGL where we could do all of our drawing. If you haven't seen that video yet, make sure you check it out because it's going to be important for this video here. And we even got a triangle onto the screen and everything looked like it was working properly, and well, it was. However, what you might have noticed in the previous video is that we actually linked something called OpenGL32.lib, and the header files that we actually ended up using for specifically for OpenGL functions were basically the ones that either GLFW provided, which in turn are just the Windows ones. Now, Windows has a graphics API already. It's called DirectX or Direct3D to be a little bit more specific. That's what Windows uses. That's what you should kind of be using, according to Microsoft, that's what you should be using to do graphics on Windows, and it makes sense. And me personally, for a real kind of game, for a real project, for a game engine, I would be using Direct3D to render on Windows because that's what's native to the platform, that's what you kind of should be using. OpenGL though, remember, is not kind of up to Windows to decide if that's a thing or not. It's up to our GPU manufacturers, it's up to the GPU drivers, and the GPU drivers from NVIDIA and AMD and Intel, they all support OpenGL as a rendering API. So what we need to do now is not really rely on Windows and their kind of OpenGL header files, which only go up to OpenGL 1.1, which is kind of the last version of OpenGL, which is also kind of the first version. 1.0 was kind of a bit weird, we don't talk about that. 1.1, OpenGL 1.1 was kind of the last, the first real version of OpenGL. And that's as far as Windows goes with it. So since we're on Windows, we need a way to actually get all of the modern OpenGL functions. I'm not even talking about modern ones. I'm just talking about anything newer than like 1997, right? OpenGL 1.1, anything newer than that. If we want to actually call those functions in our C++ code, we need to get them from somewhere. And as I mentioned in the Welcome to OpenGL video, which was the first one, again linked up there, OpenGL functions, it's not something you download really. It's stuff that is actually in your graphics drivers. The OpenGL functions are implemented in your GPU drivers. So what we need to do now is, in order to use any kind of functionality that is newer than OpenGL 1.1, we need to actually get into those drivers, pull out the functions and call them. Now when I say pull out the functions, I don't literally mean pull out the functions. What we actually need to do is basically just get the function declarations and then link against the functions as well. So,
oh wait, hold on.
Which was the first one, again linked up there. OpenGL functions, it's not something you download really. It's stuff that is actually in your graphics drivers. The OpenGL functions are implemented in your GPU drivers. So what we need to do now is, in order to use any kind of functionality that is newer than OpenGL 1.1, we need to actually get into those drivers, pull out the functions and call them. Now when I say pull out the functions, I don't literally mean pull out the functions. What we actually need to do is basically just get the function declarations and then link against the functions as well. So we need to access the driver DLL files and just retrieve function pointers to the functions inside those libraries. That's what we need to do. Now, OpenGL past 1.1, so basically modern OpenGL and all of that, there are a lot of functions. There are a lot of functions. So whilst we could theoretically do this manually, there are a few problems with that. First of all, it would not be cross-platform. So to basically access the drivers and pull out functions from that, we need to use some Win32 API calls if we're on Windows, right? Load library and load function pointers to all that. That's not great because it's going to be Windows only. And then the second problem is, if there are like, I don't know, over 1,000 functions or something like that, then we need to go through all of them manually and write code for that. That's going to just be a terrible plan. It's just not going to be fun at all. So what we're going to do now is we're actually going to use another library. Now there are a few libraries that actually do this for you, but I just want you guys to understand that what this library actually does is actually really straightforward. And you can look at the source code for this library for yourself and see what it does if you like. But basically all it does is it provides the OpenGL API specification kind of function declarations and symbol declarations and constants and all that stuff for you in a header file. And then the behind the scenes file, or the CPP file, or in this case I think it's a .c file, the actual implementation of the library goes into it identifies what graphics drivers you're using, finds the appropriate DLL file, and then loads all of the function pointers. That's what it does. That's all it does. It's very, very boring. It's not magical at all. Don't think that these libraries implement the functions or anything. They don't. They just access the functions that are already on your computer in binary form. And the library that we're going to use that does that for us is something called GLEW, or GLEW, or the OpenGL extension wrangler. There's also another library called GLAD. You can use that if you like. It's a bit more specific with extensions to OpenGL and all of that stuff, and you can configure it a little bit better. I don't really care about that. We're just trying to write OpenGL code, and GLEW does everything I need, and it's a little bit simpler. So we're going to use GLEW. So the first thing we're going to do is go to glue.sourceforge.net. Again, link will be in the description. This is the GLEW website. Again, we have the opportunity to download the source code if we want to, and that is what I would absolutely be doing if this was a serious project or a game engine. However, because this is just about learning OpenGL and this is something that enables us to write OpenGL code, I don't care about that. I'm just going to get the binaries for Windows.
Okay, let's do that. Wait. So we have glue.sourceforge.net, and we have this bar right here.
So I'm going to click on this link here, and then once it's downloaded, I'm going to open the zip archive. And
Hold on. So we have this. Let's save it.
And there'll be a folder there called GLEW 2.1.
Let me just open this and extract this. And then we have it.
In this case, I'm just going to copy that. I'm going to go back into our actual directory of our OpenGL solution. And
Let's go back right here, right?
just like last time where we put GLFW inside the dependencies folder, I'm going to paste GLEW into this dependency folder as well. Okay, so here we go. And inside that GLEW folder, we have everything we need. Now, one thing I'm actually going to do is rename this to just GLEW, okay? Not really necessary, and it does kind of strip the version. It's obviously, before it was obvious to tell that this was GLEW 2.1.0. Now you don't really know what version of GLEW is. I'm just doing this for simplification kind of purposes, just so that it's a bit easier for us. But now we have GLEW and GLFW as well. So inside this, we have a few different folders. The ones that we kind of care about for linking, as well as include and lib. This is exactly the same as linking GLFW. So that was in episode 2, check that out if you haven't already. I also just made a video about how linking libraries in C++ actually works and how you can use libraries in C++. That's linked up there, check that out for sure. That'll help you understand what's going on.
UX problems.
Fucking god.
But now you can see how they happen with session replay.
On here, because I'm going to try and keep this brief this time. So doc also includes all the kind of documentation that you want. You can see it's just an HTML format, so you can just open up index.html. That's the main web page. Let's open it in Chrome, and we have something that looks exactly the same as the web page, but you can see that this one is local. So this is where reading documentation is kind of important. If we go to usage, first of all, it tells us how to actually initialize this. Now, I'm going to point out a few issues that you might encounter with GLEW if you don't read the documentation. There's two that I can think of right now that might not be apparent. The first one is actually literally the first thing that this documentation says, and that is, first, you need to create a valid OpenGL rendering context and call GLEW init to initialize the extension entry points. So you can't use OpenGL functions from GLEW until you call GLEW init. That's the first one. And second of all, as it says, you need to create a valid OpenGL rendering context before you call GLEW init. So over here in our source code, we have GLFW init. If we were to call GLEW init here, would it work? I'm not going to answer that right now, we'll see. Anyway, back to the documentation. It tells us exactly how to kind of initialize this. GLEW init is what we call, and then we can check to see if that return code from GLEW init, if that return integer, or GLEnum, which is just an integer, is GLEW okay or not. And if it's not GLEW okay, that means we have a problem. So pretty easy to tell here. There's a bunch of stuff about extensions here as well, and all that stuff. Now, in the building section of this, we have a bunch of things that are important for building this, but again, we don't really care about that. And also in the installation section, you can see that there are some things listed about how to build the library as well, if you're trying to use it as a shared library and all that stuff. But anyway, we'll kind of explore it and find out for ourselves as well. But just another reminder, if you're using a new library, read the documentation. It doesn't hurt to do that. It might take a little bit of time, but overall you might see things that first of all are going to prevent you from accidentally doing things incorrectly and then pulling your hair out because it's not working, whereas it...
Okay, tonight I'm gonna read some documentation. Yep. And don't think I'm gonna do it live stream, but I will definitely read some documentation about, you know, OpenGL, GLU, and GLFW, and things like that. Definitely, I would definitely do this.
It appears that it should be, and also you might be able to say that, oh, I can actually use this in ways I didn't even think of. The really important thing though is that this is C++. We're writing code in C++, and C++ allows you to do things in many ways, many different ways. And especially if you're new to C++, you might think, oh, okay, every library I use follows this progression, follows this kind of style. You can't assume that. There's so many ways to do stuff in C++, and everyone thinks that they're doing it the right way. So what you need to do is read the documentation and don't make assumptions, because they might be doing something crazy. They might be defining their own meta language for certain things or whatever. You can't kind of assume that stuff, so documentation, important to read. Anyway, I've done this before, so I'm not going to read all of this right now, but let's set this up with our project. So I've extracted all of this here. Again, we've looked at the documentation. Bin contains inside release, we have x64.32, which has our DLL file. I don't really care about that because we're going to link this statically. Remember, you pretty much always want to link statically if you can. So over here inside include, we have our actual includes. You're probably realizing right now that this is exactly the path that we need to add to our actual project, to our compiler include paths, and you are correct. So I'm going to copy the end of that.
That's what I thought exactly. So let's do this right now. So we have this include right here. So let's go here and then let's go. Let's go to properties. This is kind of annoying, honestly, linking all the stuff, but let's do it right now. Solution there, and then let's paste this here, and let's hit apply. Should we do the same thing with the .lib library?
Project after dependencies,
go
to our project, right click on OpenGL, hit
so.
properties, and then I'm going to go over here into configuration. You can see set to debug. I'm just going to make sure that that's on all configurations. Platform Win32 is fine.
Yeah.
Inside C++ general, I'm going to add a semicolon to the end of this and paste in this path that I just copied, and then just stick solution directory to the front of that. Now, if there's a lot of stuff here and you don't really want to add semicolons or scroll through this, you can just drop down this box here and hit edit. You can see that we have a list of them here, and they're much easier to see. Okay, fantastic. Let's talk about linking the library now. So if we go back to our folder here, just going to go back a bit into dependencies, glue, and then lib. Now, inside release and Win32, which is the one we care about, we've got two. Which one of these do you think is a static library, and which one do you think is the dynamic library?
With this.
Well, plot twist, they're both technically static libraries, but this one is used if you want to link with the DLL. This one is used if you want to link with just the static library, because this is the entire static library. So the two things that give it away is the fact that this has an S here, and also that the size is significantly larger than the other one. Remember, if you have an S there, it probably stands for static. Again, things that you kind of just learn with experience. So this is the one that we want to link against. I'm going to copy this directory path, go into link in general, and then edit.
Oh my god. Bro, what the fuck? What the fuck are you doing? What the hell? Okay, that was weird. So we have lib release Win32, and then we have to copy and paste all of that, right? Probably.
Additional library directories. I'm just going to drop this down here to make it easier for you guys to see. Hit this new kind of thing button, and then just paste in.
Yeah, it's the right path. So let's go here and then let's add this solution there, and we'll put this here. Okay, apply. Should we also include this file? Probably we should. I don't know. I think we should also include this. So let's do it, I guess. I'm gonna do it. This is what I decided to do. I'm not following his video right now, but I think we should do this, right?
Solution directory of
Only
here
for the
and
static,
my path.
because
So
we
there you
are
go.
using
Pretty good
this
to me.
static.
And then the one we're linking with, remember, is glue. Doesn't really matter about the order here in this case either. glue32s.lib is what I want.
Yep.
Okay, fantastic.
Excellent.
Done. Now I should be able to call glue init, and also let's just go ahead and include my path. gl/glue.h.
Okay, let's do this. So we have include GL what the, I think that's the right include directory, right?
Now, if you actually look into here, the reason I know it's GL and not glue or whatever, GLW has
Directive,
GLW,
I mean.
but glue doesn't, because of course if I look in the actual include directory, there's a folder called GL and then glue.h. So remember, the path that we're specifying here is the path from this compiler include directory that we've just included. Okay, great. So back over here, you can see that this works successfully. Let's try building this. So I'll right click here and hit build. Okay, so straight away we actually get an error and it says gl.h included before glue.h. This is coming from, if we look at the output, this is coming from our actual glue.h header file. So we can double click here if we want, and we can take a look at this. So the reason this is happening is because there's literally a hash error defined, which is a compile time error that happens if these symbols are defined. So basically all this is asking you to do is please include this before you include any other OpenGL things. So GL.w happens to include GL.h. So what we're going to do is just move this glue so that it's before this, and that's it. Let's try building this again. Okay, awesome. We compiled successfully, however, we get a link error. And that link error is because unresolved external symbol, glue init. Now, we did link everything, didn't we? So what's the issue? Well, let's take a look at how glue is actually set up. If we actually go to the glue header file and we look for this glue init function, you can see that we have this glue API kind of macro defined before the actual return type. Let's take a look at what that means. And if I jump over here, we see this, as well as a comment which kind of explains it for us. So glue static is defined for static library and glue build is defined for building the DLL library. Right now, we don't have glue static defined. So what's happening is it's coming over here, glue build isn't defined, so it's coming over here, and it's actually defining glue API as extern decal spec.
Oh my fucking god, I don't care, you shut up.
DLL import, which is an MSVC compiler intrinsic, which basically tells the linker this is coming from a DLL file. You need to DLL import this. Now, we're not using the DLL version of glue, are we? We're using the static library. So if we write code like this, it's not gonna be able to link it. It's just not gonna work. We need to actually just use it like any other function. And of course, if you look up here, you can see that if glue static is defined, we don't get that kind of decal spec DLL import or export. Export, of course, is if you're actually building it. Import is for when we want to import it from a DLL. So we want to use this. And the way we do that is we define glue static. Again, something that you could definitely get if you read the documentation. But if you don't, you might have to kind of reverse engineer it and actually look at how it works to figure out how to get this stuff to compile and link. I just wanted to show you that for fun, basically. So if we go back to here, we need to define glue static, and I'm going to do that by right clicking on my project, going to properties, going to C++ preprocessor, and then
so we got, oh Jesus,
over here in preprocessor definitions, I'm going to type in glue underscore static.
Okay, so we go here. What the hell? What is this? I'm gonna add this. Probably glue static and then hit apply.
And hit enter again, making sure that I'm on all configurations and Win32. I'll hit OK, and now I'm going to build my application. Okay, awesome. So we don't get any errors here in our output, and our application's fine.
Let's try to build this. I fucking executed, I don't care. Yeah, we got it. Yep.
Fine. So, we know that glue init returns a value. If we actually look at this, you can see there's no documentation in the header file, so we need to go back here. If we go back to our usage in the documentation, you can see that this return value from glue init, if it actually isn't glue OK, then we have a problem. So let's go ahead and check that. I want to say if glue init doesn't equal glue OK, then maybe we can just print something like this.
So if we let's try to initialize this glue init. So if glue init and then is not equal to glue OK, it will probably print an error. So std out and then error glue init error or something like that, and std handle, and we should probably include IOStream, right?
Just
what happens if I compile this? Yep.
For now. And I'll put a breakpoint on this line. Before we start, I'll also have to include IOStream, of course, to use cout. So let's hit F5. Okay, so we're on this line of code. Let's hit F10. Oh no, look at that. It's not equal to glue OK, and we get an error printing. What happened? Well, remember when I mentioned whether it was okay to call glue init after glfw init, and then I asked you guys if it was, and then maybe you said something, or maybe you just ignored me and waited for the result? Well, it's not okay. We can't call glue init here. The reason we can't is because the documentation clearly states that you need to create a valid OpenGL rendering context. Where do we do this?
What does it mean?
glfw make context current.
Oh.
That is when we create that OpenGL context, okay? So what we need to do is move this code so that it's after we have a valid context and a valid window and all of that. So now...
So let's do this. So we initialize... Also, the fuck are we doing here? Wait. Oh, that's GLFW. This is the glue. Okay. It's kind of confusing, but yeah, I get it. So we have to create a context. So we will pass this here because, as the documentation states, we need a valid OpenGL context, right? So let's do that, and let's see if we have any error. And we don't. That's good. That's cool. That's good.
Now, if I move this down here, put a breakpoint here, hit F5. Now if I hit F10, look at that. It skips over this because it is okay and everything is good. And that's all there is to it. Now we have access to all of the OpenGL functions that we actually have up to the current OpenGL version. And if I want to use any of the kind of OpenGL functions that are in newer versions of OpenGL, such as GL gen buffers or something like that, you can see that I can just type it in there and it's fine. If you look at the actual glue header file, so if I right click here and go to open document, this is actually a really large.
Okay, I guess there are like 10,000 lines of code because there are multiple definitions for each mother OpenGL functions, right? Let's see how big it is.
File. If you scroll down to the bottom,
holy shit, 23,000.
You can see it's 23,000 lines of code. It might even slow your computer down a bit, but this has everything that it is. And the way that it works, if we loosely look at it, is that for a lot of functions, what it does is it actually defines function pointers, which is what all of these are. So if you were to use a function such as GL gen buffers, like I just did, it actually, and let's just make this,
this is a macro.
kind of work. So we want one buffer, at A, and it actually has to be an unsigned int. But anyway, there's our function. If we actually go to that function definition, you can see it's just a macro, it's a hash define.
Yeah.
So what we actually want to do if we want to look at the function signature is go to this glue gen buffers, and then go to the type of this function pointer. And then we get the return type, which is void, as well as the parameters it takes in, so a size and an unsigned int. But of course, we'll be looking at this and discovering a lot more of this as our OpenGL journey goes on. So that's it. That's how you initialize glue. That's how you get to the modern OpenGL version. One more thing we'll do for today is actually print our OpenGL version to just make sure we're up to date. This has nothing to do with actual glue, by the way, but it's just useful information that we should have. So what I'm going to do is once we have a valid OpenGL context, I'm basically just going to write std cout and then gl get string gl underscore version, just like that. I'm going to remove this breakpoint.
Okay, let's do this. So we initialize this, and then we can print this version. So we have cout, then gl get string. Wait, gl gets string. Yep, and then we get the GL version, right? And then we have std handle, of course. And does this actually return a string? That's a function. That's not a macro. Is this supposed to be like that? Yeah, we get it. Wow, that's cool.
Hit F5, and you can see that what it says over here is OpenGL 4.4 build blah 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 blah. I'm actually running on a laptop right now which has an Intel GPU as well as the NVIDIA one. It's obvious from this line here that it's actually using the Intel GPU for running this application. If I switch to NVIDIA, it would have said the NVIDIA driver version and probably the word NVIDIA as well as a higher OpenGL version. But it's always useful to know what you're actually running, so printing that to the console is useful stuff. Anyway, I hope you guys enjoyed this video. If you did, you can hit that like button. You can also help support this series and get rewards such as videos early, contribute to video planning, your name in the credits, all that kind of fun stuff by going to patreon.com/thechono. It really does help support the series and makes...
Let's go to the... This fucking ads. Oh my fucking god, every single time. Move, you stupid fucking bitch. I don't care about your fucking product. I'm gonna fucking refresh the page. I don't care.
My name is the Chono and welcome back to my OpenGL series. Man, I'm so excited to finally get around to doing this series. So over the last 2 episodes, which are kind of the first 2 episodes of the series, we really just were setting things up, and we were setting up GLFW and glue and basically everything we needed to be able to draw graphics in an OpenGL window. And now that's finally set up so we can start writing some OpenGL code. Now I know I keep saying this, but I just want to say it one more time. We're not making a game engine. We're just learning OpenGL here, which is why I'm not going to bother doing this properly, so to speak. I'm just interested in showing you guys what OpenGL code you actually need to write to make things happen. How you choose to abstract that and kind of move it into classes and all of that, that's your business. And certainly when the game engine series comes out, which is going to be very soon, wink, we're going to cover that anyway. So just keep that in mind. Don't expect that this is how you should write a game engine or how you should make a game using OpenGL. This is just what OpenGL code you need to write to make graphics happen and how it works. So the thing with modern OpenGL is that it's very programmable, much more than the legacy kind of OpenGL. It's pretty extensive, it's fairly powerful, there's a lot you can do with it, and as a result there is quite a lot of setup you actually need to do before you can see a triangle on the screen. Now what we did in the last few episodes, in fact in I think the first episode where we set up GLFW, is we just used legacy OpenGL. We just used GL begin and GL end to draw a triangle on the screen, because that is 5 lines of code and you're done. Here's a triangle. It's easy to just do.
Wait, which version is legacy OpenGL? Legacy OpenGL version 3.0. What the fuck? The fuck you mean? We have modern OpenGL 1.0 and 1.1. Wait, how does this work? Wait, hold on. I mean, probably the API, OpenGL 1.1. That's just GL. So we have GL 1.1, right? OpenGL R, OpenGL R graphics system is no, specification. What the hell? And we have a fucking okay, that's interesting. What is this? So this is like the documentation that the the graphics card manufacturers have to read for implementing this. Wow, there's definitely a lot of work to do. 1.1. That's not the fucking version. That's the fucking section. That's probably the specification. I don't know. Let me close this. Let me check if I switch streaming. Yeah, I am.
And it requires no setup. However, to draw a triangle using modern OpenGL, a few things need to happen. Primarily, we need to be able to create a vertex buffer, and we need to also be able to create a shader. Now, I am planning to make a video soon in the future that's just going to cover kind of how graphics pipelines work, and specifically how the OpenGL graphics pipeline works. So we're not going to get into that too much. But let's talk about what we need now to draw a triangle in modern OpenGL, because every piece of graphics that we can possibly render on our computer begins with triangle. So I mentioned two things that we really need here, right? We need a vertex buffer and we need something called a shader. Let's talk about what that even is, just quickly. So a vertex buffer is basically just get rid of the word vertex, because it's just get rid of the word vertex from that. It's just a buffer. It's a memory buffer. It's an array of bytes of memory. That's what it is. It's just a buffer. And what I mean by that is it's literally like a blob of memory in which we can kind of push bytes into there, right? And the idea is, of course, because it's tied with OpenGL, it's not just a buffer of memory, like as if I just created a char array or something in C++, and you know that's a buffer of memory, right? The difference is that this is a buffer of memory in OpenGL, which means it's actually in our GPU, in our VRAM, our video RAM. So the basic concept here is I want to define a bunch of data which represents my triangle. I want to put it into my GPU's VRAM.
Oh, so okay. That means the vertex buffer, like it's stored on the VRAM in the VRAM. Okay. That's cool. That's cool. So we have to create buffers on our GPU, right?
RAM, and then I want to issue something called a draw call, which is basically a draw command which says, hey, you know that bunch of that blob of data you've got there in your VRAM? Read from it and draw it on the screen. And furthermore, we actually need to tell our GPU how to read and interpret that data and how to actually put it onto our screen. Because once we kind of do everything from the CPU side, everything we write in C++ is just done on the CPU, right? Once we've written all of that stuff, we also need to somehow tell the graphics card, once we issue that draw call, which does come from the CPU, once we issue that draw call, we need to actually tell the GPU, okay, once you get access to that data on the GPU side, I want you to lay it out like that. I want you to draw me and rasterize me a triangle on the screen. So we need to tell the GPU what to do. So we need to program the GPU, and that's what a shader is. A shader is just a program that runs on the GPU. It's a bunch of code that we can write which runs on the GPU, and in a very specific way and in a very powerful way, which we can explore in the future. But that's basically the gist of it. Don't overthink it too much. We just basically have a bunch of memory that we can specify, right? A bunch of data that I can specify, tell the GPU, hey, here's this data, and then from the GPU side say, okay, now read this data and interpret it as like a bunch of positions on your screen maybe, and join them up into a triangle. That's kind of how this whole thing works. And that is I guess the foundation, the basics of all of this kind of OpenGL rendering code. It's just what I've just described there. Have some data, then draw me something. Now, it's really important to note that OpenGL specifically operates as a state machine. What that means is that you don't necessarily treat it like an object or anything like that. What you do instead is you set a series of states. And then when you say something like, hey, draw me a triangle, that's very contextual. What I mean by that is, instead of me just saying, hey, draw me a triangle, and then passing in everything that OpenGL needs to draw the triangle, it actually knows already what it needs to draw the triangle, because that's part of the state. So to put it another way, you basically say, I want you to select this buffer. I want you to select this shader. And then draw me a triangle. Right? And based on which buffer and which shader you've selected, that's what's going to determine what triangle gets drawn and where and all of that stuff. That's how OpenGL works. It's a state machine. That can be annoying. In fact, it probably is annoying, but that's just how it operates. Learning that and just knowing that is just very important for OpenGL in general, so keep that in mind. And
so it's okay, it's a state machine, okay. Yeah, it basically keeps a memory of what you select, what buffer you are pointing, right?
so with all of that in mind, I do want to keep this series a little bit more practical, so let's just write some code to create this vertex buffer and see what we can do with that. Okay, so what we have here is what we kind of wrote in the first episode, which was this basic triangle that we drew by specifying 3 vertices, right? And we did this by using legacy OpenGL, which was very easy to do. What we now want to do to basically draw this according to modern OpenGL is create a vertex buffer which just contains, well, this data. There it is, that's our data. We just want to actually put that into a buffer, send it to OpenGL's VRAM, and...
Wait, hold on. What is this while loop? Oh, it's right here. Okay. So this is loop until the user closes the window. Render here. Swap. And GLFW terminates. And that's interesting. Okay, this is where we initialize GLFW. This is the window, right? Because the kernel say to us that GLFW init. I mean GLFW is the library itself actually handles the window and some events, right? Then it creates a window. And if it encounters an error, it will terminate and exit, right? With the status -1, so the process will return -1. That is the error, right? Make the Windows context current. Yeah, that's what we need. We need a context, right? And I know I didn't understand what a context is exactly, but we have window here, and then we have to initialize glue after we create the context, right? So we initialize glue init, and then we print the version like from the string. This is a macro. What is this? Well, this is like an hexadecimal number, probably like some code that OpenGL understands probably, but yeah, this is like there's a bunch of defines here, like that's the file that he was talking about before. Yeah, that's the glue, and there are over 23,000 lines of code. This is crazy. This is incredible. Oh my god, this is. So we have like GL API entry, and is this a pointer? That's a pointer, right? What is this? Oh my god. That's an STD call. And what does that do? It calls the Windows a Windows a Windows API function with this. And what is this exactly? So the STD call calling convention is used to call Windows 32 API functions. The callee cleans the stack, so the compiler makes a var functions cdacl. The fuck is this? Functions that use this calling convention require a function prototype. The std call modifier is Microsoft specific, so this is a Microsoft thing. And like the Chern explained before, we are using Windows, right? So we definitely need std call, like to evoke, to actually evoke the Windows API functions, right? So that's what we need, and that's cool. That's interesting. So if the find Win32, so this is specifically for Windows 32, and we have WinGDI API, and then we have some. Ooh, that's interesting. We have some definitions right here. That's the GL version 1.1. Interesting. So it's the it's the latest modern OpenGL version. Okay, that's cool. And then we have this bunch of definitions right here, and then we have each bindings, like we have the bindings for each functions, and yeah, there are so many functions right here, right there. And what is this? What is glue? GLU. Is this lightning related or texture? Probably. We also have GL 1.2.1 and 1.3. What the hell? And we still have all of this stuff. Like we have the bindings. Like we have function bindings, right? That it's binding us to the driver functions, and okay, let's keep going. So we have the SD call, and for all function not explicitly declared with a different calling convention. For compatibility with the previous version, SD call is a synonym of SD call. So these two are like kinda equals, right? So So for the Windows API, we have this standard call. Okay. I definitely need to learn about the Windows API and low-level stuff, right? For now, I'm more focused on the web applications and how JavaScript work and the some frameworks. But I will definitely do an exhaustive research probably, and I will study it really deeply about the low level stuff because that's pretty interesting. And I don't know if I will do it live stream, but that's kind of interesting. Also, another cool thing, I know the C programming language, so that will be helpful, right?
Later issue a draw call saying, hey, draw my buffer please. So to do that, we're definitely going to want to go outside of our while loop. This is just our games loop, right? We don't want to be doing this every single frame. We can just define a buffer to begin with, and then we can actually fill it with data. And then inside the game's render loop, we can just say, hey, draw the data that already exists. If for some reason we would require to actually change that data frame to frame or something like that, we can do that as well by just updating the buffer, and that's totally fine. But for now, since of course we're not changing this data, you can see that our triangle is not morphing into something else or anything, it's just a bunch of static vertices. We can kind of do that outside of this game loop. So over here, I'm going to define my vertex buffer. And the way that this works is pretty simple. You just type in gl gen buffers, right? Then you specify how many buffers you would like. So OpenGL can generate morphing into something else with, and then we can actually fill it with data. Oops. And then inside the game's render loop, we can just say, hey, draw the data that already exists. If for some reason we would require to actually change that data frame to frame or something like that, we can do that as well by just updating the buffer, and that's totally fine. But for now, since of course we're not changing this data, you can see that our triangle is not morphing into something else or anything, it's just a bunch of static vertices. We can kind of do that outside of this game loop. So over here, I'm going to define my vertex buffer. And the way that this works is pretty simple. You just type in gl gen buffers, right? Then you specify how many buffers you would like. So OpenGL can generate you a bunch at once. We just want one buffer, so I'm going to type in 1. And then we need to give it a pointer to an unsigned int. You can kind of see here that this function returns void. So instead of returning the ID of what we generated, we instead provide it with an actual integer, and it writes into that integer's memory.
So we need to create... Oh my fucking god, this fucking... I don't care, kill yourself, bitch. Stupid fucking...
So what do you do?
A pointer. So what I can do is just type in unsigned int, I'll just call it buffer, and then pass in the memory address of this unsigned.
Yeah, we need this. And that's what I was about to do until this fuck-ass ad popped out of nowhere and ruined everything. So we have unsigned int. I'll create the buffer. So I guess we have to pass this, right? Probably. Yep. Okay, it's already written here, but I didn't saw it, and yeah, of course you would need a fucking pointer, because how can you assign this?
Now, what this is the ID of the generated buffer. Remember, OpenGL works as a state machine, which means that everything you generate, again, this is contextual, so basically what I mean by that is textures will have kind of their own stream, buffers will have their own stream, but everything you generate in OpenGL gets assigned a unique identifier. It's just an integer, 0, 1, 2. 0 is commonly kind of an invalid state, but not always, so again, something you need to learn, which we'll cover in the future. But basically you get a number back, like 1, 2, 3, whatever. And that's an ID for your actual object, whether that be a vertex buffer, a vertex array, a texture, a shader, anything, right?
So everything has an ID in OpenGL. Okay.
Get a number, an integer back, which represents that specific shader. And then you basically just use that number whenever you want to use that object, right? So if I want to bind or select my buffer, because I'm just about to render my triangle and I need to specify which buffer to use to render my triangle, I just pass in that integer. It's like, hey, can you select buffer number 2, please? That's how OpenGL works. So that's what this is. This is generating a buffer and giving us back an ID. So now we have an ID. Once we've created an actual buffer, we now need to select that buffer. And selecting in OpenGL is called binding. So I just type in gl bind buffer. Now this is the target. So I've generated a buffer, but how do I want to use it? Like, what is the purpose of all this? For us, this is just a buffer of memory. So we're going to use gl array buffer, which basically just says, this is just an array. And then you can notice that we do pass in the ID of the buffer. So this is the buffer that we're binding. And of course, it's the one that we've just generated.
Array buffer.
Pretty simple so far. Hope you guys are keeping along with this. And so the next logical step is obviously to actually, well, put data into that buffer. You may have noticed also that I haven't actually specified how large this buffer is or anything like that. I've just created a buffer and I've bound it, meaning that I'm just about to work on it. So the next step is going to be to actually specify the data. Now there's 2 ways you can do this. You don't really have to provide it with data straight away. You just have to specify, when you create a buffer, you usually specify how large you want it to actually be. So for example, I don't know, 200 bytes or something like that. And then you have the option of straight away giving it data, or you can just give it nothing and then later update it with data. That's totally fine. Since we obviously know the triangle that we're drawing right now, we might as well provide it with data straight away. So I'm going to type in gl buffer data, and then again we specify the target, which is gl array buffer. The size, meaning how big we want this buffer to actually be, or how big our data is. So in this case, let's kind of calculate this.
Wait, I still don't understand what does gl array buffer mean. Like, I know it's an array buffer, but I want to know exactly why do I have to press this multiple times first. Second, what does it actually do?
We have all of these vertices here. Let's actually declare them as something else. Right now they're just kind of numbers here. Let's make a float array which contains all of these, right? So I'm going to write float positions equals, and then we'll kind of make an array out of it. So first of all, I'll define how many I want. You can kind of just define arrays like this in C++, but I like to be a bit more specific. So we know that we have 6 vertices by looking at this, 6 positions. So I'll just put in 6 here, and then I'm actually going to specify them. So literally, if I scroll down here and copy this, I'm holding Alt, Shift, and then clicking from the kind of the top to the bottom here. Control.
Okay, let's do the same thing. Oh my fucking god, why is it a mess? Alt, Shift, and then, ooh, wow. And then I will probably create a new what is this, float positions. Okay, we'll specify the size and then we'll pass everything here, kind of like this, right? Then we should, I'm gonna align this properly. Holy shit, this is so probably like that. I tried, okay. Yeah, I kind of tried.
C, Control V, and there we go. We have our vertex positions. Now I like to kind of align them as well. We have to add commas here as well. But I like to align these, so I'll just put space here, make sure they're nicely aligned, and then we have a basic buffer. You could also call this a buffer, right? Because it's an array of contiguous memory in which we have 6 floats. So over here we need to specify the size. Now, because this array was created on the stack, I could just say size of positions. I'm really not a fan of doing that though. So what I'm going to do instead is just say 6, because we know that we have 6 floats times, well, the size of a float. So it's important to note that this size is in bytes. Now you might be wondering, how on earth do I know that it's in bytes? And the answer to that is, well, of course, experience, but you also should be reading the document. This size is in bytes. Now you might be wondering, how on earth do I know that it's in bytes? And the answer to that is, well, of course, experience, but you also should be reading the documentation. So this is a good chance for me to show you guys what I think is probably the best documentation website for OpenGL, and that is docs.gl. So I'll put a link to this in the description below. Basically, this is a huge kind of documentation resource here for OpenGL. It has a lot of OpenGL versions, including kind of the embedded systems version, so the mobile versions of OpenGL, as well as GL2, 3, and 4. So what we're going to do up here is just type in the name of our function, which is GL buffer data. I'm going to click on GL4 because that's the version that we're using. And then over here you can see that there are two overloads. Well, there's one called named buffer data and one called buffer data. Well, obviously this is the one we're interested in. You can see there's our size variable or our size parameter that we're passing in. If we scroll down, we can look at the size, and you can see that it says specifies the size in bytes of the buffer object's new data store. Okay, and then you can see also for data, which is our next parameter, specifies a pointer to the data that will be copied into the data store for initialization, or null if no data is to be copied. So you can see just by reading the documentation, bytes. Obviously this is the one we're interested in. You can see there's our size variable or our size parameter that we're passing in. If we scroll down, we can look at the size, and you can see that it says specifies the size in bytes of the buffer object's new data store.
Yeah.
Okay, and then you can see also for data, which is our next parameter, specifies a pointer to the data that will be copied into the data store for initialization, or null if no data is to be copied. So you can see just by reading the documentation how easy it is to see how you can use this. Like for example, we now know that we can just pass in null if we don't want to provide it with any data to begin with. The usage is also something that's important, so it specifies the expected usage pattern. So basically the idea with this, and I think if we scroll down here, you can see that there is the usage is a hint to the GL implementation as to how a buffer's object data store will be accessed. So with that in mind, we can specify stream, static, or dynamic in here, which is basically, stream means that it's going to be modified once and used at most a few times. Static means that the data store contents will be modified once and used many times, right? So that's actually the one we're leaning towards, and I'll tell you why in a minute. And dynamic, the data store contents will be modified repeatedly and used many times. So the reason static's important, stream is not something that we use too often, to be honest. Static and dynamic are kind of the ones that we care about. Static just means that it's going to be modified once and used many times. What that means is you can see that we're going to create this buffer once, and we're not going to modify the buffer every frame, but we are going to draw it every frame. So that's what it means by used many times. It's going to be drawn like every frame, in this case, our triangle. Whereas dynamic is something where the data store contents will be modified repeatedly and used many times. So if we were also modifying this triangle, modifying these vertices every frame and drawing it every frame, we would be using dynamic.
So we usually use dynamic, right? So because we have the same shape moving, right? Probably.
Now these are just hints, meaning that if I declare this as static, and then I draw it, and then I update the buffer every frame, it's still going to work. It's probably just going to be a lot slower, so just keep that in mind. This isn't like a set in stone kind of thing, it's just a hint. In fact, it says here in the notes that usage is a hint to the GL implementation, okay? So with that in mind, we now know how to fill this out, hopefully. So the data that we're going to provide it with is just going to be a pointer to this positions thing. Now this already is an array, so of course we can just write positions. And finally,
so let's pass this
GL enum usage. So that's the usage that we just talked about. We want to use static. So GL underscore static underscore draw. Now, I didn't talk too much about the draw thing, but of course we will be drawing the actual triangle, so draw is the one that we care about. Okay, cool. So there we go. We've actually specified a bunch of positions for OpenGL, and that's really all we need to do. Now, normally we would also want to create something called an index buffer, but we're going to have another video about that in the future because I don't want to make this video too long. But basically what we can do now with this data, theoretically, is draw it. Now we don't have a shader to actually specify how the data is being drawn, and we're actually going to talk about that in the next episode. But what we will do today is just see if we can draw it anyway, and we'll just see the code required to draw this as if we did have a shader. So back here, this is all the code we need to actually give OpenGL the data. However, whilst we've given OpenGL the data, we haven't actually told it what the data is. Remember, OpenGL is literally, if you kind of look at this, receiving a void pointer of data. It's receiving a bunch of bytes. Now, how on earth is OpenGL supposed to know how to interpret those bytes, right? They're just a bunch of bytes. We haven't specified that, hey, we've given you 3 vertices, they're floats, and also we've given you 2 vertex positions kind of per vertex, or two floats represent 1 position, which is a vertex, right? We haven't said any of that. What if we have texture coordinates or normals or other things? And it doesn't make any sense. OpenGL can't just magically be like, oh, I see what you've done. You want me to draw you've kind of specified 2-component or 2D kind of coordinates, and you just want me to draw a triangle with them. No, not how it works. We need to actually tell OpenGL how our data is laid out. And that is something that we definitely need to do, because remember from the
Oh my fucking god.
side, we want to be able to read this data in an appropriate way. For example, this kind of vertex position that we have up here, I'd love to just be able to read that as a 2-component vector, right? As a vec2, or maybe even a vec4, so that I can multiply it with a matrix in my shader or something like that. We need to be able to tell OpenGL how our data is laid out. And we can do that by using a function called GL vertex attribute pointer, okay? Now that is, again, something that is very closely tied with shaders, so we're not going to talk about that today, but just keep that in mind. We're not really ready to draw yet. But if we were, let's take a look at that. So I'm going to scroll down over here, and instead of having this junk here where we render triangles using immediate mode, I'm actually going to issue a draw call for this buffer. And the way that we do that is very simple. There's 2 main ways of doing that. There's GL draw arrays, which is something that you do if you do not have an index buffer, and we don't have an index buffer, so we'll look at that. You can see that we need to specify the mode that we're drawing.
Wait. Oh my fucking god. What? Right, yeah. So we have GL draw arrays, right? Wait.
For this buffer. And the way that we do that is very simple. There's 2 main ways of doing that. There's GL draw arrays, which is something that you do if you do not have an index buffer, and we don't have an index buffer, so we'll look at that. You can see that we need to specify the mode that we're drawing in. What this means is what kind of primitive are you trying to draw. In this case, we're trying to draw a triangle, so we just type in GL triangles. The first is basically just an offset. Again, you know, documentation, right? I know all this, but for your sake, let's go ahead and take a look at what GL draw arrays actually does and how it works. So first specifies the starting index in the enabled arrays. So in other words, if we for some reason wanted to start from the 2nd vertex, we would type in 1 here, right? Because we start at 0. We do want to start from the beginning of our kind of list of vertices, so I'm just going to write 0. And then finally the count, which is the number of indices to be rendered. Now, indices kind of means vertices in this case, so we have 1, 2, 3 of these. Yep. So you just type in 3. And theoretically, if we hit F5 to run our program, you would see a triangle. However, since we've written like 30% of the...
Wait, hold on, what the hell? What the fuck? Hold on. Okay, that was a weird glitch, a weird IntelliSense glitch. Okay.
Program, you would see a triangle. However, since we've written like 30% of the code needed to render a triangle, you're seeing a black screen. But this is basically the idea. The other draw call that we have is something called GL draw elements, which is something that we use with an index buffer. So in this case, we kind of specify the same thing, GL triangles, then the count, so 3, the type, which is actually the type of the...
So we have GL draw... Wait, GL draw elements, right? Now you have GL we always have GL triangles, and we have the count, so 3. Wait, what? Yeah.
Index data, so if we're using like an unsigned int or an unsigned short, we would put that in there. And then finally a pointer to the indices, which we almost never use, so that's usually just null. But again, we'll look at that when we look at what index buffers actually are. So that being said, that's the draw call.
Okay.
Right? This is the line of code that actually draws our triangle. Now you may notice here that it doesn't specify, well, anything. I mean, it says that it's a triangle, it says that we're starting at 0 and we're drawing 3. How does it know to draw this one? And that comes back to me saying that OpenGL is a state machine.
Yeah, it just select. It's just probably because. Okay, let me guess. We have binded this, so since it's a state machine, and we lastly binded this, we OpenGL will automatically select this buffer, and this buffer will contain these positions, and this will be drawn, right?
When we were writing this block of code, and we wrote this code right over here, GL bind buffer,
Yeah.
that is what is going to be drawn, the one that is currently bound. If before we did this, we bound no buffer, which you do by binding 0, then this would not draw our triangle because we've selected something
Wait,
else.
bind,
I like to
okay.
compare this to using a program such as Photoshop, when you select things in Photoshop. If I select a layer and then draw something on that layer using the paintbrush, it's going to affect that layer. However, if I have nothing selected or I have the wrong thing selected, obviously it's not going to be affecting the layer that I want to draw on. OpenGL is the same. You need to select everything or bind everything before you actually do stuff with it, because that's how it works. It's very contextual. It's a state machine. Anyway, I hope you guys enjoyed this video. It's a bit of an introduction towards vertex buffers. We've still got a lot to cover, including kind of all the vertex attribute stuff, shaders, and index buffer kind of objects. That's what we've kind of gathered from this video, that we need to do a lot more work. But that is the basics. Hope you guys enjoyed this video. If you did, you can hit that like button. Leave any comments you may have in the comment section below. If you want to talk about this stuff with a lot more people, you can join my Discord by going to thechannel.com/discord and joining it there. There's a bunch of people there and we talk about this stuff all day long, so it's a good time. Also, if you want to help support this series and you want to see more episodes, as well as get access to all the source code that I write in these videos, episode by episode, then you can support this series on Patreon by going to patreon.com/thechurno. You'll get some pretty cool rewards. You may have noticed the on-screen credits at the beginning of the video. That's what you get by being a cool supporter, and there's a lot more kind of stuff, as well as getting these videos early, which I think is pretty cool. Anyway, hope you guys enjoyed this video, and I will see you next time. Goodbye.
That's interesting. Yep. I'll probably read the documentation tonight. Like, not everything, but at least I will start reading it. And but for now, I will end the stream. Thank you so much for watching, and I will see you the next time. So, good night, everyone.